Hello, everyone. This is Colleen Lumsden, and on behalf of Sectigo and 451 Research, I would like to welcome you and say thanks for attending today's webcast titled Making Zero Trust Possible. Leading off the discussion today will be Aaron Sherrill, who is Senior Analyst at 451 Research. Following Aaron will be Tim Callan, who is Senior Fellow at Sectigo. Just a few quick housekeeping items before we get started. To ask a question, simply type it in the question box on your screen and we will get to as many as we can. The presentation slides are available for download in the resources section on your screen. And finally, please check back for the on-demand version of this webinar after the conclusion of the live event. And with that, I'll turn it over to Aaron.
Hey, thanks, Colleen, and thanks everyone for joining us. I believe we have a great and timely topic to discuss today. So here is our roadmap for our discussion. We're going to start off by spending a moment just to level set and briefly review how the evolution of IT and security has gotten us to where we are today. We'll then define zero trust because, like many terms in the IT and security world, zero trust has come to mean many different things. Then we'll take a look at some of the common components of zero trust, many which you may already possess, and then we will wrap up the first part of the webinar reviewing some of the key capabilities needed for zero trust, and then where do you start on a zero trust journey. Before we get started, let me take just a moment here and give you a little background on 451 Research for those that may not be familiar with the company. 451 Research is an information technology research and advisory company with a core focus on technology innovation and market disruption. Last year, we became a part of S&P Global Market Intelligence, where our team delivers insight through research, advisory services, live events to organizations around the world. And this is interesting. We publish an enormous amount of information, research, and data. The quantitative side of 451 Research generates over 52 billion data points each quarter, and our qualitative team publishes over 4,500 reports each year. We spend a lot of time talking with vendors and service providers and enterprises as we analyze really this global IT ecosystem. We're looking to identify market trends and really separate fact from hype so we can help enterprises, service providers, and vendors really make informed decisions about their organizations. And as Colleen mentioned, my name is Aaron Sherrill. I'm a senior research analyst focused on information security. And prior to coming on board 451, I spent over 20 years working in IT and in InfoSec, served in a variety of different roles, including CTO and VP of Information Security. Also had a stint working in information technology for the FBI. So I'm very familiar with the pains, the issues, the challenges that many of you are facing today around delivering and securing IT services. All right, so as we get started, I want to take a couple minutes to set the stage for our discussion. And I think one of the best places to do that is think about, where we came from. It wasn't that long ago that most employees sat behind a well-defined perimeter, using a corporate desktop to access corporate data and applications that all pretty much lived on premise. For the most part, if you were on site using a corporate desktop with an internal IP address and you could authenticate to the network, you were pretty much trusted. You could pretty much access anything on the internal network. And that concept is true today. Look at VPNs. Most VPNs grant you access to entire network segments, not just the specific apps or data that you need to do your job. But today's world is very, very different. We have employees, customers, partners, suppliers, and really even services from unknown locations using a variety of devices and methods to access data and applications that are living across a hybrid, diverse, and disparate IT ecosystem. If I was giving this presentation back in January, I think we all would agree that the IT world is vastly different than it was just a decade ago. But, here we are, just 5 months into 2020, and many organizations look vastly different than they did at the beginning of the year. I think it's safe to say no one expected the massive shifts we've all experienced. Let me take a moment just to highlight some of those shifts. So over the month of March, we surveyed organizations about the impact of COVID-19 and how that was impacting their organizations. Now, this data is about a month old, but at that time, over 65% of organizations had already expanded work-from-home policies, with another 10% said they were going to do so soon. And over a third of organizations expected those new policies to remain in place for the long term and become permanent. We will be conducting another COVID-19 impact survey in just the next few weeks, and I expect that we'll see these numbers grow even further. By the way, if you're interested in the findings of this survey, you can find this and other COVID-19 related reports freely available on the 451 Research website. All right, so back to the changes that we're seeing from this new work from home trend. It's creating new trends that are going to probably last well beyond the pandemic. The leaders of several well-known, very traditional but complex organizations have recently stated how well they've been able to function with the majority of their workforce working remotely. I think they've been very surprised. I think those organizations that have been slow or reluctant in the past to embrace remote workers, they're quickly seeing the value of the impact that a mobile workforce can bring to their organization. In fact, I just saw earlier this week that one company in particular said that work from home was going so well that they would not be reopening over 50% of their global offices following the pandemic. So while we had this growing mobile workforce that is using a variety of devices and methods to access data and applications, the very data and applications they are accessing are increasingly moving to the cloud. In a recent survey we did, we asked enterprises about IT environments and where they're going. And while the cloud is playing an increasingly significant role in transformation and modernization initiatives, a hybrid IT environment that leverages both on-premise systems and off-premise cloud and hosted resources is now the formal IT strategy for over 71% of enterprises. And this strategy is resulting in significant shifts of workloads to both public and private cloud environments. So we have this growing mobile workforce and a significant increase in data and workloads that will be residing off-premise. So does this mean the perimeter is dead? I think we've seen this play out in a lot of articles and posts, and I think that may be overstating things just a bit. Now, the traditional perimeter is becoming less relevant for a number of reasons, but I think the perimeter still exists. It's just moving, and I want to talk about that more in just a moment. As we've seen, the infrastructure for most enterprises is becoming very complex. A single organization may operate several internal networks, have remote offices with their own local infrastructure. They have a growing mobile workforce and an expanding number of cloud services. And all this complexity has really outstripped traditional methods of perimeter-based network security. It's really becoming increasingly difficult to point to a single, easily identified perimeter for the enterprise. The perimeter is moving from the edge of the network to the very edge of devices and data and applications and the workloads we want to protect. We need to create a data-centric perimeter around information. And, this is where zero trust comes in. So first, let me clarify. You've probably heard this before, but zero trust is not a product. It's not a one-and-done project. It's not something you're just going to wake up one day and decide to do. You just can't buy your way into zero trust. Zero trust is a framework, and while the term may be relatively new for most security teams, the concept has been around for well over a decade. From a high level, zero trust is primarily based on who you are rather than where you are, as access maybe has historically been. Zero trust is really an extension of the principle of least privilege, and that's only granting access to things that people need specifically. They need to do their job and nothing more. So, zero trust is just as it sounds. It's an environment or a way of operating that is completely untrusted. So this whole zero trust movement has revived the phrase we all know: never trust, always verify. But I think a more accurate way of thinking about zero trust is trust nothing and challenge everything. Zero trust, this concept of extending a minimal amount of permissions to devices and users and services and applications, so they can only perform a specific business function. That's not anything radically new. For many IT and security teams, it's something that really we've all been trying to do all along. So why all of a sudden, are we looking at this so differently? Well, I think it's because how we've been doing this does not work in the distributed, disparate, hybrid, mobile world. And while the current adoptions of zero trust are still pretty low, enterprises have indicated that they have high intentions to leverage zero trust in the near future. For the most part, adoption to date has been hampered by the technology needed to make zero trust security practical. Until recently, the technology has been too immature, and the disruption it creates is just too risky for most enterprises to consider. As with many new technology concepts, zero trust has been seized upon by companies eager to sell packaged solutions. And the result has been some confusion and misconceptions about zero trust. So, Colleen, it looks like I'm unable to forward the slides at this time. We should be on slide 13. If you could move that for me.
I see that we are on slide 13.
Okay, great. So, just my side's not refreshing. That's fine. We'll work through it. So, I think NIST has articulated zero trust well. And this is from a recent special publication draft around zero trust architecture. So zero trust is the term for an evolving set of cybersecurity paradigms that really move network defenses from these static network-based perimeters, and we're going to start focusing on users, assets, and resources. It is focused on resource protection, and the premise is that trust is never granted implicitly, but must be continually evaluated. So as a side note, if you're interested in rolling out zero trust, I highly recommend checking out the 800-207 publication from NIST. So as we move forward to the next slide, as we discussed a moment ago, zero trust is not a product, but it is a framework, a security model. It is a set of principles that is used for system design and operations. A zero trust approach is primarily focused on data protection, but it can be expanded to include enterprise assets such as devices, infrastructure, and users. The zero trust security model assumes that the enterprise-owned network infrastructure is really no different and no more trustworthy than any non-owned enterprise network. So, a zero trust approach requires that the enterprise continually analyze and evaluate the risks to its internal assets and business functions, and then enact protections that mitigate those risks. And that's not an easy task. We're talking about all requests. So all meaning every file request, every database query, every print command, every resource access must be checked to make sure it comes from a user or a service or a source that has the correct privileges at that moment in time. There can't be any assumptions, and there really can't be any exceptions. So as I mentioned a moment ago, zero trust is a hot topic for enterprise security teams, and vendors have been quick really to embrace this concept. And as a result, they have produced many new terms that are basically are different names for zero trust. For example, the whole zero trust movement really got a boost by Google with BeyondCorp, which was basically an internal Google project to revamp their entire security architecture from the ground up. Other terms used by vendors include conditional access, adaptive access, software-defined perimeter, identity-defined perimeter. Really, all these things essentially mean the same thing: zero trust. So, we've talked about how we've got here and some of the drivers and challenges facing us today. We took a stab at defining zero trust. So now let's take a moment and talk about the end game. So we're on the next slide here, the goals of zero trust. And, what does that look like when we have a zero trust model or a framework in place? So again, I'm going to use some of the data from this publication I referenced earlier because it simplifies us all very well. First, this is what it looks like. All of our communication is secured regardless of network location. We already mentioned this a moment ago, but in a zero trust environment, network location no longer implies trust. Access requests from assets located inside the traditional network perimeter, they have to meet the same security requirements as access requests from any other non-enterprise owned network, user or device. So the second goal, once we have this zero trust environment in place, then all access to individual enterprise resources is granted on a per session basis. Trust in the requester is evaluated before the access is granted. This means authentication and authorization to one resource will not automatically grant access to a different resource. So the third goal, access to resources is determined by dynamic policy. And this is, including the observable state of the client, identity, application, and the requesting asset. So really what this means is dynamically assessing a broad range of attributes, meaning evaluating maybe a version of the software installed on the device, the network location the request is coming from, maybe the time and date of the request, previously observed behavior. The list goes on, and there's just many, many attributes we can make these decisions. These attributes are what the policies or access rules are based on, and then assigned to a user a data asset or application based on the needs of the business processes and acceptable levels of risk. So moving on, once we have this zero trust environment, the enterprise ensures that all owned and associated devices are in their most secure state possible, and then monitors those assets to ensure that they remain in their most secure state possible. No device, regardless who owns the device, should be inherently trusted. And devices that are discovered have known vulnerabilities or are not managed by the enterprise, should maybe be treated just a little bit differently than those owned by another enterprise, another individual. But regardless, in the end, you need to ensure they're all in their most secured state. And this even applies to personally owned devices that maybe you allow employees to use to access some resources, but not others. And then finally, the second to last goal here is all resource authentication and authorization is dynamic and strictly enforced before access is allowed. This is a constant cycle of attaining access, scanning and assessing threats, adapting, and continually evaluating the trust in ongoing communication. So continuous monitoring with possible re-authentication and reauthorization occurs throughout a user's interaction. And that's defined and reinforced by policy. So really what we're trying to do is strive to achieve this balance of security, availability, usability, and cost efficiency. And then finally, the last goal. The enterprise collects as much information as possible about the current state of the network and infrastructure and communications, and then uses that to improve its security posture. An enterprise should collect data about network traffic, access requests, and then use all of this information to improve the policy creation and enforcement, and use that to maybe provide context for new access requests. All right, so there we go. We defined what zero trust is, and we painted a picture of what zero trust looks like when it has been implemented. But where should an enterprise use zero trust? So really, zero trust should and probably could be utilized just about everywhere. But if we think about this more specifically, zero trust really shines in several specific use cases. We saw earlier how a large percentage of enterprises now have formal hybrid or multi-cloud infrastructure strategies. And, cloud providers secure their own infrastructure, but it's still up to the customer to lock down access to data stores and workloads that they own. And this is no simple task, right, because each cloud operates differently. So as we expand into more cloud environments, the level of management complexity increases exponentially for security teams. And Zero Trust can really help minimize the overhead in managing these disparate security of these environments. Remote access is another great use case, and it's very timely considering the expanded work-from-home initiatives that we discussed earlier. Zero Trust is being used to replace the revered VPN, which has been the go-to for remote access for decades. But that VPN model no longer works in a modern business environment where corporate assets are really no longer in one physical location, but now they're spread across multiple clouds and hosted in different compute environments. Another use case is non-employee access. In this instance, Zero Trust not only provides more granular access controls, but it really provides security teams with greater visibility into which partners are requesting network access, what data paths they're using, what systems they're talking to, and really what constitutes normal traffic patterns from partners. And then another common use case is branch offices, but for the sake of time, I'm not going to go into details on that one, and we'll move forward to the next slide. So let's shift gears for just a moment, and let's talk about some of the components of Zero Trust. We said this earlier, but Zero Trust is not a singular technology. But it is characterized by a variety of technologies that range from strong identity and access management to data security. There are many products and tools and components that can help make a Zero Trust possible. While not all of these are a must-have to implement Zero Trust, they tend to be quite common in many Zero Trust initiatives. So, all of these technologies and these capabilities, they're great. But having an effective Zero Trust architecture, I believe there's a few fundamental things that security teams really must get right first. The first one is automation and orchestration. These are becoming critical capabilities for security operations. I often talk to enterprises about their automation capabilities. Many feel like they're highly automated, but when we dig down to it, all they've done is created many standalone scripts to automate very specific tasks. Now, that's a great start, but Zero Trust is really going to require security teams to take automation much further and make full use of security automation orchestration tools, because they need to automate tasks across all of their security products, all of their workflows, and really integrate disparate data from security information and management systems and behavioral analysis tools. Next is visibility and analytics. In order to create, build, and enforce Zero Trust principles and policies, security teams must have visibility into everything going on across the entire IT ecosystem. And not only that, they've got to be able to make sense of it all. So that's so they can orient their defenses and their policies more intelligently, and in order to develop more proactive security measures. Because bottom line is, if you don't know what you have or you can't see it, then you really can't govern it or protect it. Segmentation is another key capability for Zero Trust. Access policies won't work without proper segmentation of data and resources. By splitting segments of an organization's infrastructure into these different compartments, Zero Trust can protect critical data and resources from unauthorized users. It really reduces the attack surface by keeping vulnerable systems walled off and prevents a lateral movement of threats throughout the network. If you remember earlier, we asked, is the perimeter dead? And I mentioned it wasn't dead. I think it's moving, and this is what I meant. The perimeter is no longer at the edge, but it's now surrounding the very assets and data we need to protect. So in essence, now we've created many micro perimeters or micro segments that we need to manage and protect. And lastly, a key capability, and this one's often overlooked, but it can't go without saying, PKI. And I know at this point, if you're like me and you've worked with PKI in the past, you're thinking, oh man, that's a deal breaker because I've worked with it in the past. It's difficult to deploy and maintain. if you haven't looked at PKI management lately, I can tell you that's no longer the case. And Tim's going to talk about that more in just a moment, but let me tell you, PKI is an essential element in addressing data privacy and data security throughout a zero trust implementation. PKI is at the core of security. Think about Wi-Fi authentication, web application authentication, email security, domain login, securing remote access or securing IoT devices. PKI enables encryption and confidentiality and non-repudiation and is essential to prove identity of devices and users and applications throughout the network. In the quest for data integrity and secure credential management, PKI has long proven its effectiveness, and it should be a foundational part of any zero trust strategy. All right, so as we wrap up the first part of today's webinar, we've discussed what is zero trust, what is the end game for zero trust, what are the components and capabilities of zero trust. So let me wrap up with this. Where do we start? With a few exceptions, I think most discussions around implementing a zero trust architecture really focus on systems being built from scratch. But as you know, in the real world, most of us are trying to deploy a zero trust model into existing networks, and that's a much bigger challenge. So the thing to recognize is zero trust is a journey. There's multiple avenues to get to zero trust. It's not a product. It's not a wholesale replacement of infrastructure processes. And while it's not overly expensive from a technology acquisition aspect, the time commitment can be challenging for most organizations. I really recommend that organizations seek to incrementally implement zero trust principles. In most enterprises, I believe they're going to find that they're going to continue to operate in this hybrid zero trust, traditional perimeter-based mode for an extended period while they continue to invest and evolve their zero trust initiatives. How an enterprise migrates to zero trust largely depends on its current cybersecurity posture and its operations. But at a minimum, I think organizations need to take the following steps before deploying zero trust in their environments. So first, you got to take inventory. With zero trust, you don't focus on your attack surface, but you focus on your protect surface. That is the critical data, applications, assets, and services that are most valuable for your company. Now, I know this is not groundbreaking. It's not overly exciting. But, a comprehensive data discovery is a critical first step to zero trust because, at the end of the day, it's the data you're trying to protect. And if you don't know where your data is, then you can't properly protect it. Just a word of caution here, don't underestimate this seemingly trivial step in your zero trust journey. This step can be very demanding. It can be long and painful, especially considering all the demands on IT and security teams. And at the same time you're doing this, I suggest you start assessing and understanding what controls already exist within the enterprise that can help with enforcing zero trust access policies. You also want to look at mapping resource interactions. The way traffic moves across a network really determines how it should be protected. So you really need to understand the interdependencies of your assets to properly establish and enforce controls and long-term minimize disruption that zero trust and how it could impact your users and business operations. And next, you need to architect your zero trust environment. Zero trust implementations are typically completely customized. They're not derived from a single universal design. So once you've defined the surface to protect and map, then you can map out your zero trust architecture. In zero trust, you need to design from the inside out. Now, this is contrary to how most of us learn. Most of us take the security view from the outside in. That's how I learned, right? You start at the firewall, you start at the perimeter, and you work your way in. But in zero trust, you need to think about micro perimeters and micro segmentations across layers 2 through 7. Tight controls create isolation layers between endpoints and enable secure connections for end-to-end users connecting to those critical assets and resources. Once that network is architected, you'll want to zero in on zero trust policies, determining access to assets. You need to know who your users are, what applications they need to access, why they need to access it, how they tend to connect to those applications, and what controls you can use to secure those assets. And then finally, you want to monitor, reiterate, and expand. So this includes reviewing all of your data, all of your logs, all of your network traffic, and really focusing on the operational aspects of zero trust. And then since zero trust is really an iterative process, you'll take all this data to help provide really valuable insights how to improve that zero trust architecture over time. So let me leave you with this last point before I hand it over to Tim. Overhauling an existing network to zero trust security, it's not easy, but I think it's one that can greatly strengthen an organization's overall security posture. And with that, Tim, I'm going to hand it over to you.
Thank you, Aaron. Hi, everybody. My name is Tim Callan. I am a senior fellow at Sectigo, and Sectigo is, we are a leader in the area of digital identity, in particular PKI and certificates. And I, too, do not appear to be advancing the slides. Are they advancing, Colleen? Am I just missing that?
Yep, they're advancing.
So, okay, great. So we are, and in particular, I've included a diagram here of, Sectigo is in a variety of areas. We are a public CA. We're the world's largest commercial public CA, so we do actually issue certificates that people use. But what I want to focus on today is the middle section of this diagram, which I hope everybody's seeing, which is explains the which is that our digital identity on automation platforms in particular, and these are the things that we are we're using to advance the. I'm sorry, I just don't know what slide I'm on right now. Am I on the slide with the three sections, Colleen?
Yes, you are.
Okay, great. So the middle section here these are really the platforms that we're looking to talk to today, which is what's going on, how you use automation to provide digital identity to your for your system. So what I want to do is I just want to build on what Aaron said, and these are just meant to be some visual aids that we can use to build on what was already said. So let's just go ahead and do that. And the first point probably to understand is that, when Aaron talks about digital identity and zero trust and all of these different concepts, this really applies to every digital actor that you might have in your environment. So this isn't just users. This isn't just web servers, though it is users, it is web servers. It is any server, any device, any process, anything accessing your cloud, any application that's in your cloud. All of these actors, any IoT device, all of these actors that are doing anything anywhere in your digital environment must be secured with strong identity. If they're not secured with strong identity, these wind up being subject of attack. And this has happened in many environments, in many places, over and over again. And there are long lists of where companies had breaches and had loss of data and had outages where that might not have occurred or would not have occurred had they employed this kind of strong identity across everything they do. And Aaron talked about how kind of your grandfather's IT setup, where there was a single floor with servers in a rack and every machine was in the building and they were all owned and set up by the admin, just isn't reality today. And, talked about some of the ways that it's not reality. You might be on multi-cloud, you might have IoT devices, you might have BYOD devices, all of these things, computers, on different operating systems. And one of the big ones is just a heterogeneous technology stack. There was a day where I might say that everything in my enterprise is ultimately Windows, right? There are desktops and servers, and it's all Microsoft. And that just isn't the case anymore. I've got lots of devices from Apple, I've got Linux, I've got other things out there all floating in this big cloud throughout my system, and it's unpredictable, and it's changing, and even what you have today might not be what you have in the future. And so all of these different ways that people or processes or devices might get into your system can all be secured with PKI. And typically that means a digital certificate. Sometimes it means a key pair, but usually it means a digital certificate, and there's good reason for that, because certificates are for the most part better and more robust, and really are the recommended way to do this kind of connectivity, because they have life cycle and they have more control and they automatically expire and things along those lines. And you can look at you can look at all of the different ways that you might connect to your you might connect your systems, and this could be desktop as a service or Windows Hello or VPN, and by way of examples, this way for people to come in. Again, it might be autonomous devices that are existing on their own. It might be people's laptops or IoT devices or BYOD devices or mobile devices you assign. All of these different elements and pieces all connect in various ways, and they all need to be, they all can use PKI for security. And PKI today, as Aaron mentioned, this is not old-fashioned PKI. If you've used PKI, if you sat and used it 10 years ago and you felt like you had to develop things from scratch, that is not the way PKI works anymore. PKI today is a very robust, purpose-built kind of system that you can use exactly like you would use for any other set of computing processing you might run. And so the slide that I have here is just kind of a visual aid for some of the things that you need in a PKI system to make sure that it works well for you. And I'll just call your attention to a couple of them. One of them is scalability, right? So you can scale your PKI to match any reasonable use case that any enterprise organization in the world might have. And just, an example of this is if you look at something like a DevOps environment where containers are being created and destroyed as needed, and they're being created in huge numbers, and the number is wildly flexible, and a container might only last minutes or seconds. Each one of these containers needs a cert. And so you have a PKI system that is just pumping these certs out for these containers. And we have customers who are using our system throughout their entire DevOps environment, and there's no problem in terms of volume. Or another example of that is IoT, right? You can have people issue just massive numbers of IoT devices. And all these devices, every one of these devices needs a cert, because that's where digital identity comes from. And once again, there's absolutely no problem with the volume. So scalability is one thing that you do not need to worry about, right? That is a thing that a modern PKI system can handle for you, as opposed to people, right? Humans don't scale very well. And PKI, in contrast to that, scales very, very well. Another one I want to point out to your attention here is the concept of interoperability. So this is a big one, right? We have all these different systems. They come from different vendors. They come from different places. They're on different operating systems. And interoperability can really hang you up, right? As our systems get more and more complicated and they depend on each other, if you have a problem, first of all, it can be hard to locate. Second of all, it can be incredibly devastating, and it can waterfall, right? You can have cascading failures where one problem leads to another problem, leads to another problem. And so interoperability helps you, ensuring your interoperability helps you stave off those kinds of problems. And you really need to think about this in two ways. First of all is just in terms of trusted roots. So any PKI system you have, it's a certificate authority system, which means at the top of that there's going to be a CA, and it will either be a public CA from somebody like Sectigo, or it'll be a private CA that you own internally. And either way, you have to be really careful to ensure that all of the roots are able to be trusted by all of the devices and systems that need to see those roots. So if you're standing up your private CA, you don't want to stand up a private CA in location A and something else in location B, and you have your systems try to talk to each other, and somewhere along the line a machine is seeing a cert that it doesn't recognize the root for, because then you'll have a failure. Now that can be solved through using public roots, which is one of the approaches that people take, or it can be solved by using a coordinated single pane of glass approach, where all of the different devices and pieces you're talking about are all in one integrated system where you can ensure that every cert is known and understood, right, and is coming from the same place. And those are both viable approaches, but either of those is important in interoperability. The other thing to think about with interoperability is common protocols and common PKIs, right? APIs. So ultimately, X509 certificates are based on interoperability. That's why we use them, right? Because everybody knows what the standard is, and all sorts of different systems can use the same standard. But even within that, there are measures you can take for interoperability. And a great example of that is ACME. So ACME is a relatively recent certificate automation protocol that has been widely popular, that has huge widespread support. And the great thing is if you choose to use something like ACME and write to ACME or put ACME inside of your systems, you can rely on the fact that many other systems, services, sites will understand ACME as well. It's this very widely utilized and widely supported API. And as a result, you can take ACME, you build it in there, and you have lots and lots of devices and things that where your interoperability will just come automatically. And it'll be reliable, and you'll be able to take that to the bank. So, Aaron talked about automation and various other aspects that are extremely important. One other aspect that I think I'll just discover here is Aaron talked about the idea of taking an inventory of what you have. And we're big believers in this, and the way we normally describe this is we talk about what we call certificate discovery. And one of the things that happens a lot in the common enterprise is that certificates, so again, once upon a time, your grandfather's IT organization or your father's IT organization, what happened was there was a single department, and that department got every cert that anybody ever had. And it was real simple, and they knew what they all are. And that's not how it works anymore. Things are diversified. We have developers who live inside of lines of business or roll up to specific departments, or we have skunkworks projects, we have outside firms and outside contractors, and any one of these folks in any place might stand up some certs. They might obtain some certs, put them online, and this starts running a critical system. And the system is inside of your very complicated network of systems and services inside your environment, and things are depending on it, and it's all running great, and you're making money, and it's improving customer sat, and it's improving employee productivity, and then whammo, one day for some reason it's not working and nobody knows why. And so often it turns out that the reason why is because a certificate that nobody knew ever existed just expired. And so the consequence of that can be enormous. And so we suggest discovery, right? We suggest that you get an automated platform that can go through and find all of the certificates in your environment. And once you find them, it can bring them under management so that you can see what they all are. And you don't even just know things like these are expiring on these days, which is hugely important, but you also know about the certs themselves. Are the key lengths long enough? Are they using hashing algorithms that we trust and believe in? Are they compliant with other requirements that we have due to our SLAs or our industry requirements or things along those lines? Are we auditable? And all of that becomes possible through discovery. And so certificate discovery is incredibly important. Now, again, doing this manually is ludicrously labor-intensive and error-prone. And so this is where an automation platform really helps you a lot, because it will go through, it will be thorough, it will be complete, it will report everything in a single report where you can see it, or a single interface where you can use it, and all of that will be consistent across all of the different uses. So in the spirit of time, I think we were going to talk some about Sectigo Certificate Manager. I've touched a lot of what Sectigo Certificate Manager really should be. let me just move to this slide right here. So Sectigo Certificate Manager is Sectigo's platform that does all of these things for you. So it works with all of the different certificates and key pairs you might have in your organization for all different use cases. You know, includes web servers, DevOps, cloud, IoT devices, company-owned devices, employee-owned devices, email, etc. So all of those certificate types can be managed in a single interface. You have a single pane of glass. You can search, report, automate renewal, automate replacement. You can revoke. You can check certificates to make sure that they're valid and compliant. You can output reports that you can use for your own internal audits and your external audits. And all of that is built together in one platform in one place where you can use it. So, you know, I'm sorry if I was a little discombobulated because I can't actually see the slides, but you know, that's really what I wanted to cover today. Is you know, this is what we're doing with our platform. It's being used by many enterprises around the globe, and is a very you know, it's very robust, and it works even up to the largest implementations. So I know I'm running out of time. I'm going to do a quick plug for my podcast. So I do host a podcast called called Root Causes. It's a security and PKI podcast where we dive deep, my co-host and I dive deep into all sorts of matters involving digital certificates and PKI. We try to cover the full gamut of what's going on in the industry, and it's a very busy industry. So we wind up publishing a lot of podcasts. We'd love to have you listen to us. You can come to iTunes, Spotify, SoundCloud, etc. Wherever you listen to your podcast, if you search on Root Causes PKI, you should find us. And, you know, check out what we're talking about, and we'd love to have you as a guest. And with that, let me hand it back over to you, Colleen.
Thanks so much, Aaron and Tim. It's now time for our Q&A session. As a reminder, simply type your question in the box on your screen, and we will get to as many as we can. Those that we aren't able to get to live, we will respond to offline. So the first question for today is, how do digital signatures and SSL certificates differ from each other in a zero trust scenario?
Okay, so an SSL certificate is a kind of, Aaron, I hope it's okay if I take this. An SSL certificate is a specific kind of certificates. There are a number of specifically defined public X509 certificates. SSL's one, S-MIME's another, code signing's a third, etc. And so SSL certificates are the most general purpose and the most used of them. They basically pretty much can secure any server for any machine-to-machine connection. So SSL certs are the things that make the lock icon happen, so that when we go to bank online, we see the lock icon and we know that it's secure. But they're also the things that make all of your servers in your constellation talk to each other. And they're also the things that are used in DevOps environments for containers. Those are also TLS certificates, which is the official name for what we call SSL. So that is a set of use cases that's very broad. And the vast majority of the certs that you're using in your environment are probably going to be TLS, unless you have like a big IoT implementation or something along those lines. Digital signatures, that's a little bit of a general term. It can mean a lot of different things. Certainly a digital signature can be used when we talk about digitally signing documents. That is digital signatures. That's a use case I didn't even talk about, but it's huge, especially with work from home going on now, right? Where we're used to push paper around. Now instead what we're doing is we're using certificates to assure that we've really signed this electronic document, and usually it's PDF, and that we're signing those PDFs or we're signing those Office documents, right? So that's how the word digital signature is most commonly used, but digital signature is a little bit of a squishy term, so it might be applicable in some other contexts as well. And then there are, like I said, there are other certificate types as well in the mix, but they're at a high level, they're all doing the same thing, which is that they are ensuring the identity of some kind of digital actor in a way that is unspoofable and in a way where data are unchangeable or immutable. So like when you digitally sign a document, by way of example, you can't tamper with that document. If you tamper with that document, the digital signature blows up. So one of the things that that signature is doing in that context is ensuring that the document is identical to how it was when it was signed. If you look at the TLS example, it's enabling encryption, so you get an encrypted session. So what's happening is the certificate is also ensuring that nobody is modifying that stream as it flows across the network or across the internet. So what originates at point A is also what arrives at point B in an unmodified form. So in that sense, they're all doing very similar things. They're just crafted for the very specific use case that they're needed for.
The next question is for Aaron. There is a lot of marketing around zero trust. How can I best navigate the market and separate hype from reality?
Yeah, that's a great question. So, there is, as I mentioned earlier, a lot of marketing hype. A lot of vendors have gravitated to this term zero trust because it's like I said, a lot of enterprises have goals to implement this over the next 12 months. So there's a lot of people saying they can, with their single tool, with their single solution, that they're going to implement zero trust, and that's just not the fact. I think I'm going to point you back to what we said earlier. This is what if you take that last slide in my section about what the zero trust journey looks like. First, again, it's not exciting. It doesn't seem like you're getting anywhere, but really to identify that data surface that you need to protect. What are the assets and resources and data points that you need to protect? What do you already have within your current security infrastructure that you can already use? And then start looking at what holes maybe you need to fill, or what initiatives do you need. Maybe that's identity and access management. That's a significant gap for a lot of people. It could be maybe you're going to do that incrementally, maybe a single sign-on and multi-factor authentication. I would ignore for the first part as you're getting started on your zero trust journey. Ignore a lot of what a marketing vendors say. Focus on those core components we talked earlier: automation and orchestration, segmentation, PKI. Focus on those core capabilities. Focus on that zero trust journey of identifying your data footprint you need to protect, and then looking at the tools that you need to bring in to move your zero trust initiatives forward. So take that incremental approach.
And the next question, do regulations like GDPR affect how I approach digital identity?
So yeah, there are a lot of regulations and industry standards that GDPR, CCPA is another one, right? The California Consumer Protection Act is getting a lot of visibility right now. A lot of these regulations, HIPAA High-Tech, GDPR, CCPA, et cetera, require that consumer data be protected. And so it's important to be aware of what your requirements are to do this protection. And sometimes they even go so far as to talk about control of access or to talk about encryption, right? And whether or not they state them specifically, it's pretty widely accepted that those are requirements in order to protect these things. So, if you're doing everything to be completely secured and protected anyway, that is probably meeting your GDPR, CCPA, et cetera, requirements. But on the other hand, if you're not, that certainly can be one of the many ways that comes back to harm your organization. Aaron, do you want to add to that?
No, I think you've covered it well, Tim.
Great. And the next question. I've been hearing that quantum computers will break encryption. Do I have to worry about that?
Let me take this one. So yes, quantum computers will break encryption. That's not really a question. So quantum computing approaches computing in a fundamentally different way, and as a consequence of that, the fundamental mathematics that sit underneath of our common encryption algorithms, which are named RSA and ECC. RSA and ECC are used by I don't know how many nines, 99.999% of use out there, right? They're ubiquitous. They're everywhere. RSA and ECC, as it happens, mathematically are both going to become many orders of magnitude, 10 or 12 orders of magnitude faster to compute with quantum computers than they are with traditional binary computers. And what that's going to do is that's basically going to mean that our existing approach to encryption must change. So one of the things I didn't talk about in my slide with the wheel was crypto agility. But the concept of crypto agility is that once upon a time, when we first started doing this back in the 70s and 80s, basically people made encryption algorithms and they kind of figured like that was that, we're done. And what we've learned over the years is advances in science, advances in math, advances in cryptography, and advances in computing have caused cryptographic schemes to be temporary. And they last for a long time. They might last for a decade, but they don't last for eternity. And so the idea behind crypto agility is that we need to have systems that can be modified and updated to stay current so that our secrets stay secret. And the latest example of this is quantum cryptography. So there's a concept called quantum safe crypto. And basically there's a big effort going on right now. It's a combination of academics, government, and industry to come up with a series of quantum safe algorithms. And we're very confident that those exist. They just need to be refined. And the quantum safe algorithms will work, and we will be able to replace RSA and ECC, and we'll be using those. So, you know, it's important to understand that the chances are very good that 3 years from now, you are no longer signing your certs with RSA or ECC. You're probably signing or hashing them, I should say. You're probably hashing them with something new. And that is coming. And one of the important reasons to have automation in place is when that comes, again, discovery. We want to know what all of our certs are. We don't want old quantum unsafe certs sitting out there being subject to attack. We also need to transfer them over in a reasonably fast time frame that isn't going to break our back. And automation can enable that for us as well. So yeah, that's coming, and that's absolutely something that, not today, but in the next 2 years, every enterprise in the world is going to have to think about and deal with.
And the next question, what are some of the challenges or weaknesses of using the zero trust model?
Yeah, I can take this one. So, and there's a lot of challenges. I think with all the strengths that a zero trust model has, it does make creating security policies a lot more complicated. One of the things the zero trust model lacks, and back to one of the earlier questions, is just there's no really out-of-the-box solutions. There's some tools available that can help, but they're not going to secure the entire network. It's only going to leave you with a partial solution, and a lot of weaknesses. I think one of the biggest challenges, and I've mentioned this a couple of times, is the time to implement zero trust. Reorganizing policies within your network can be difficult. Especially as you're in that transition phase. As you reach a certain demarcation point, it'll start to become bigger, but especially as you're in that hybrid mode, it becomes really, really difficult to manage that transition. You're going to have a lot of employees that have to be monitored more closely. You got devices that have to be managed and monitored more closely, applications that have to be monitored and managed more closely. There's just a lot more to manage at a much deeper or more granular level. Again, it's going to improve security, no question about that, but it does require more work to get to that end goal. And I think that's what may derail a lot of zero trust initiatives because, as I mentioned earlier in the presentation, a lot of the tools that are out there have not really been ready until recently. And then the amount of effort that's required to implement this on top of all the other initiatives that we have going on right now, it's really hard, I think, for a lot of organizations to make progress. So, do this in an incremental fashion, and maybe you're going to have zero trust just around web-based applications to start with. That may be a great place to start. And so there are ways to do this very incrementally. It doesn't have to be a full all or nothing type of approach. In fact, if you take that approach, you're probably going to fail. So again, there's a lot of challenges, but I think the upsides far outweigh the challenges of getting to that zero trust model. It's not a clear path. It's not a universal model to get there for everybody. So, to discover that along that journey for yourself and your organization, that's going to be a challenge.
We have time for one final question. Twitter recently made permanent work from home an option for all of its employees, and other companies surely will do similar things. How does that trend affect what you've been talking about today?
Yeah. There's going to be more emphasis. This is the point Aaron was making, right? Like if we had given this webinar in January, it would have been a very different webinar than we're giving today, right? We talk to companies about this a lot because we're sort of their trusted consultant, and I'm sure you guys are also, Aaron, in terms of how to implement these sort of access control. And, companies are coming to us saying, I used to have single-digit percentages of my employees who are access remoting, and now it's going to be high 90s percentages. And, what the heck do I do? I would say that, there's an important point, and this is in the research you showed, Aaron, which is that, it's never going all the way back. Like, even if you don't go to a pure work from home model, the pendulum is not going to swing back as far as it was. And, having large quantities of peoples outside your physical perimeter who are accessing your essential goods is the new normal. And you've got to deal with that, right?
Yeah, I agree, Tim. I think this is a new norm. I think, the question, you're asking, how does this affect what we're talking about today? I think it just makes it more impertinent and more imperative, especially as we're talking about remote access. I talked a minute ago about doing this in an incremental fashion. That may be an area you want to focus on first. These traditional VPNs, they're not really built for today's modern infrastructure. We talked about this disparate multi-cloud hybrid infrastructure. VPNs really aren't really built well to manage that. So, a zero trust model is really gaining headway for a lot of remote access initiatives. So that may be another area I think that we'll see zero trust take off in, and whatever a lot of people will focus.
So, Aaron, if I can ask you a follow-on that. So, we've seen, you showed us research, and we all obviously know about the idea of the humans leaving the physical premises as we are all working from home and sheltering in place. Is there a corresponding increase in interest or activity around moving processes physically out of the premises, so taking more on-prem work streams and turning them into cloud-based work streams? Is that something you guys are perceiving or hearing about?
Yeah, that's definitely happened, and it varies between industry and company to company, especially where they are on their digital transformation journey. That's something that never ends. But this has really expedited some of those things that have been on the menu of initiatives that corporations have been looking at over the last year. So we're seeing a lot of those get expedited, and especially as we have, and we've mentioned multiple times, an increasingly mobile and diverse workforce that's probably going to remain that way for some time. So yeah, that is definitely a movement we're seeing happening or picking up steam. It was already happening prior to the COVID outbreak, but it's definitely happening at an expedited rate.
Yeah, so that's part of the new normal as well.
Yeah.
Gotcha.
Thanks so much, Aaron and Tim. That concludes today's webcast. As a reminder, the on-demand replay will be available on On24 soon. On behalf of Sectigo and 451 Research, thank you so much for attending, and have a great day.